Jai Hind dosto, this is Prajesh and welcome to AirPra. Today we are covering the second part of detonation mechanism and warhead know-how, which was divided into two parts. The first part covered contact fuses, proximity fuses and fragmentation in weaponry. If you missed that part, please check the description below for the links. So today in the second part we are delving into the latest generation of warheads equipped with modern weapons. So let's dive into this. There are several types of warheads presently employed in modern weaponry systems. However, in the landscape of 21st century warfare, characterized by its technological advancements and diverse combat scenarios, there are 5 primary types of warheads that stands out for their widespread usage and effectiveness, such as continuous rod warhead. This is a specialized explosive munition intended to optimize its impact on soft targets, commonly utilized in anti-aircraft and anti-missile missiles. Unlike conventional explosive warheads that generates a spherical blast, a continuous rod warhead generates a focused blast pattern by releasing a series of metal rods or fragments upon detonation. An example of this type of warhead is the AIM-9 Sidewinder missile, which exhibits an annular blast fragmentation pattern, dispersing in a large circle upon explosion, effectively penetrating the target. These rods, typically made of steel or other high-strength materials, are arranged radially around the explosive charge within the warhead casing. When the explosive detonates, the casing ruptures and the rods are propelled outward in a predetermined pattern. This results in a cone-shaped blast wave with a high velocity and kinetic energy capable of penetrating and shredding the target. As you can understand by this video, continuous rod warheads are commonly used in air-to-air missiles and air defense systems such as surface-to-air missiles due to their ability to effectively engage dispersed or lightly armored targets such as aircraft. Shaped charge, an explosive device specifically engineered to concentrate its energy in a particular direction, maximizing its penetration capabilities against armored targets. It consists of an explosive material enclosed within a metal casing, within a conical or hemispherical cavity facing the target, as its effect is purely kinetic. Within the cavity, a metal liner or shaped material, typically copper or another high-density metal, is precisely shaped to focus the explosive force into a narrow jet upon detonation. Upon detonation of the explosive charge, the metal liner collapses and forms a high-velocity, high-temperature jet of molten metal that penetrates the target's armor with immense kinetic energy. In military, shaped charges are commonly used in anti-tank weapons, artillery shells and improvised explosive devices (IEDs) due to their ability to defeat heavily armored vehicles and fortifications. They are prized for their effectiveness against hardened targets and have revolutionized modern warfare tactics and weaponry. Here is an example of a missile equipped with a shaped charge warhead, such as the AGM-65 Maverick. High explosive anti-tank warhead, in short, HEAT. This warhead is a specialized munition designed to penetrate armored vehicles by utilizing a shaped charge mechanism. It typically consists of a high explosive filler encased within a metal cone or liner. Upon detonation, the explosive charge collapses the liner, forming a focused, high-velocity jet of molten metal. This jet penetrates the target's armor through a process known as Monroe effect, where the intense kinetic energy and localized pressure bridge the armor, causing spalling and fragmentation inside the vehicle. HEAT warheads are highly effective against armored vehicles due to their ability to defeat both traditional and reactive armor. They are commonly used in anti-tank missiles, rocket-propelled grenades, in short RPG, and other guided munitions. While HEAT warheads are primarily designed for armored vehicle targets, they can also be employed against fortified structures and bunkers, making them a versatile assets on the modern battlefield. One of the prominent examples is the AGM-114 Hellfire and NOG anti-tank missile. Tandem-charge. This is a specialized explosive device designed to defeat reactive armor and other forms of armor protection commonly found on modern armored vehicles. It consists of two explosive warheads arranged in a tandem within a single munition casing. The first warhead, known as the precursor or standoff charge, is detonated at a distance from the target. Its primary purpose is to neutralize any reactive armor or countermeasures, such as explosive reactive armor (ERA) that may be present on the target. Once the reactive armor is defeated, the second warhead, called the main charge, is triggered to penetrate the vehicle's underlying armor and cause damage to the target's interior. This sequential detonation allows the tandem charge to overcome the protective measures of armored vehicles more effectively than traditional single-stage warheads. Tandem charges are commonly used in anti-tank missiles and rocket-propelled grenades (RPGs) to enhance their armor-penetrating capabilities on the battlefield. Here are a few examples for you. Missiles equipped with tandem charge include the BGM-71 TOW, FGM-148 Javelin, and Brimstone missile. In penetrating weaponry, dual charges serve to enhance the effectiveness of warheads against structures such as bunkers. This is due to the tendency of a single high explosive charge to dissipate much of its force to the surrounding air if detonated outside the target structure, following the path of least resistance. To address this issue, heavily constructed gravity bombs with delay fuses are employed. These fuses allow the bomb to penetrate the earth or concrete, etc. of the target before detonating. By containing the explosion within the structure, this method significantly amplifies its impact. For instance, the Storm Shadow missile utilizes a tandem-charge BROAC warhead specifically designed to penetrate hardened structures. An armor-piercing warhead is a specialized type of projectile designed to penetrate armor protection, most often including naval armor and vehicle armor. Typically composed of a dense metal such as depleted uranium or tungsten alloy. It possesses exceptional kinetic energy upon impact, enabling it to breach thick armor plating. The design of the warhead frequently incorporates a hardened casing to endure the impact forces and guarantee penetration. Upon detonation, it directs its energy in a concentrated manner, optimizing its capacity to overcome hardened defenses. The initial significant use of armor-piercing projectiles was to penetrate the thick armor found on numerous warships and inflict damage to their lightly armored interiors. Armor-piercing warheads represents vital components in contemporary military arsenals, providing accurate and efficient methods to neutralize fortified adversaries. For instance, the BrahMos cruise missile of Indo-Russian origin is equipped with an armor-piercing warhead. Well, this video covers some of the most frequently used warheads in weaponry, showcased here in approximately like 12 minutes. However, if you want me to increase the length of the videos, please leave a comment. I hope you have understood the characteristics of warheads overall. So in the next upcoming video, we will delve into tail chase engagement, head-on engagement, and electronic countermeasure in aerial warfare. But for that, you must hit the like button, subscribe, and also write your comments about what you would like to see in the next video. So take care, stay curious, and see you in the next video, okay? Bye-bye.